In this video, we're going to be solving the definite integral from 0 to pi of e to the sine cubed x plus cosine cubed x divided by 1 minus sine x times cosine x multiplied by cosine to the fourth x minus sine to the fourth x dx. So first, we're going to want to simplify both of these chunks of trigonometry. We're going to want to simplify this exponent. Then we're going to simplify this term. First, let's simplify the exponent. Let me write the exponent out. We have sine cubed of x plus cosine cubed of x, all divided by 1 minus sine x times cosine x. So I look at the top, the numerator, and I see we have something cubed plus something cubed. We know we can factor that because we know that a cubed plus b cubed is equal to a plus b times a squared minus ab plus b squared. So we can rewrite the numerator as sine x whole cubed plus cosine x whole cubed. So sine is a and cosine is b. So we write it as sine x plus cosine x, because a plus b, times a squared, so sine squared x, minus ab, so it's going to be sine x cosine x, plus b squared, so cosine squared of x, all divided by 1 minus sine x times cosine x. Okay? Now, if you recall from our trigonometric identities, we know that sine squared x plus cosine squared x is equal to 1. And if you look what we have here, we have a sine squared x added to a cosine squared x. This means we can replace the sine squared x plus cosine squared x with 1. So now we get sine x plus cosine x times sine squared x plus cosine squared x becomes 1. And then we have the minus sine x cosine x divided by 1 minus sine x cosine x. So now, as you can see, we have a common 1 minus sine x cosine x in the top and the bottom, so we can happily cancel that. Now all we're left with is sine x plus cosine x. So now we can say that our integral is equal to the definite integral from 0 to pi of e to the, now the exponent is just simplified to sine x plus cosine x multiplied by our thing that we had here, cosine to the fourth x minus sine to the fourth x. Alright, now let's simplify this. So to simplify this, we have to notice that we have a difference of squares. Recall that a squared minus b squared is equal to a plus b times a minus b. And in this case, we can rewrite this whole expression as cosine squared x squared minus sine squared x squared. So this is going to give us that this is a and this is b. So a plus b is going to be cosine squared x plus sine squared x multiplied by cosine squared x minus sine squared x. And if you recall again from our trigonometric identities, we know that sine squared x plus cosine squared x is just equal to 1. This whole thing is equal to 1, and 1 times anything is itself. So we can just say that this is equal to cosine squared x minus sine squared x. But if we look at this again, look, it's a difference of squares. Again, it's a difference of squares. Again, we can rewrite this expression as cosine of x whole squared minus sine of x whole squared. So now this cosine of x is a and this sine of x is b. So now we can rewrite this as a plus b, so cosine x plus sine x, multiplied by cosine x minus sine x. Alright, so this is going to be our final simplification. Let's rewrite the entire integral. We have the definite integral from 0 to pi of e to the sine x plus cosine x multiplied by cosine x plus sine x times cosine x minus sine x dx. So you might be asking, what do we do now? Well, there's a clever substitution that we can make. If we let u be the entire exponent we have here, sine x plus cosine x, then du just happens to be cosine x minus sine x dx. And look what we have here, cosine x minus sine x dx right here. And well, you might be asking, what about this term? Well, cosine x plus sine x is actually equal to sine x plus cosine x, which we defined as u. So we can rewrite this exponent as u, because we already defined it as that. We can rewrite this term as u, because addition is commutative, right? Doesn't matter what order. And we can write the cosine x minus sine x dx as the du. So all in all, we have the definite integral. Now be careful here, because we still have to change our bounds. This lower bound of 0 turns into sine 0 plus cosine 0. Sine 0 is 0, so we don't care about that. Cosine of 0 is 1, so we just get 1 for the lower bound. 1. And for pi, we just get sine of pi plus cosine of pi. And sine of pi is equal to 0, so it's irrelevant. Cosine of pi is equal to -1. So we have a -1 right here. And let's just rewrite this out. So we have e to the u now times this u and then du. And now this is a simple integration by parts problem. We can set, so we have the integral of u dv equals uv minus integral of v du. Let's choose our u and dv. We have u to be the one that's differentiated, so we can differentiate u pretty easily. So let's just set u equal to u. And let's set dv equal to the one that's easily integrated, so e to the u equals e to the u. Differentiating u, we just get u, or differentiating u, we just get du is equal to 1. And integrating dv, we get v is equal to e to the u. So now, multiplying the u and v together, we get u times e to the u, and we subtract the integral of v times du. So v times du is just e to the u. So our antiderivative is going to be u times e to the u minus the integral of e to the u du, which we know is e to the u, and our plus c. However, this plus c is irrelevant now because this is a definite integral, so we can just cross that out. Alright, so we have to evaluate this at our bounds, and note that 1 is our lower bound, not our upper bound, and same for -1. -1 is our upper bound, not our lower bound. So we have to evaluate this at 1 and -1. So first let's evaluate it at -1. We have -1 in place of u. So negative e to the -1 minus e to the -1. And then we subtract. Now we evaluate this at u equals 1. At u equals 1, we just have 1 times e to the 1 minus e to the 1. That's just e minus e, which is 0. So we have minus 0. So now this is equal to negative e to the -1 minus e to the -1, right? And e to the -1 is just the same thing as 1 over e minus 1 over e. And we have our final answer as -2 over e. And that's the value for this integral. And the decimal approximation for this answer is going to be around -0.736. And yeah, that's it. We solved the integral.